Hi BasilCon, my name is Maxwell Elliott, and I'm a member of the iOS Developer Experience team at Tinder. I'd like to walk you through today why we chose Basil as our build system and how we transitioned and ultimately cut over to using Basil for all builds. Let's start first with a little bit of a history lesson from 2019. Our developers were frustrated with the flakiness of our tests and the fact that we had to run all the tests for every single change. Our toolchain was unstable and constantly broke due to transitive dependency mismatching issues with our locally installed tools. Debugging these errors took our team hours to resolve. Simply setting up all the needed binaries in our toolchain required pairing for several days to get up and running. Modularization was stuck in the mud. There was no easy way for our team to make new modules, and there was a fear about the proliferation of modules due to the impact of startup time. Build times are outpacing the growth of the team, breed exponential growth. The support of this system was greatly exceeding our capabilities. We needed to rethink our entire build to move forward. We started first with our toolchain management, a constant source of issues for our end users. This led to the creation of what we call the Basil Hermetic toolchain. Having outgrown our previous toolchain system, we needed something that guaranteed hermeticity and reproducibility, two traits that were very much lacking in our previous system, Homebrew. We also knew that we could not build our toolchain from scratch, so we need to consume pre-built artifacts or support caching built artifacts. Basil appeared as the perfect candidate for this workflow, and the strong active community was an invaluable asset in this choice. Basil's HTTP archive functionality was a perfect fit for these binaries, and running them on the clients. Clients could no longer interfere with these binaries, making support much more streamlined. Developers were trained on a new way to invoke these tools, which removed learning Basil as a blocker for this effort. This migration was done largely in place and had no impact on our developers whatsoever. This gave the team a powerful entry point to using Basil, while demonstrating to the team that this technology could solve significant problems. Given the success of this approach and the ease of the migration, we then decided to apply these learnings to our internal toolchain to supercharge our team's impact with Basil. Prior to this effort, our internal toolchain was largely composed of SPM-built executables that were committed directly to the repository. Additionally, for the source code for these tools lived alongside the source code of the primary Tinder iOS application, thus inheriting its CI performance characteristics. It was at this moment our team needed to define the principles we stood for building these tools. First, we wanted to imagine an optimal developer experience, what it might look like. Based on our experiences of our prior setup, it meant extremely fast iteration cycles, isolation from the large Tinder iOS repo, exhaustive test coverage, and defensible quality metrics. Swift would be used to consolidate programming languages and encourage contribution. All Swift code would be built by Basil to demonstrate the efficacy of this build system for this use case. With these principles in mind, how did the team execute in this new environment? Here are some metrics from our internal tooling code. What started off as a simple goal turned out to be a step change in the capabilities of our organization. By using Basil, unlocking huge wins in velocity, we realized a whole new world of automation. These wins allowed the team to scale up many more responsibilities without additional support burden because all tooling logic is covered by tests. Given the smaller nature of the iOS tooling build, it served as an excellent test bed for one of our most powerful open source tools, BasilDiff. As part of our investigation of Basil, we really wanted a build tool that was able to test only the minimum required set of targets for every change. To us, this seemed like the holy grail as a CI experience. We just didn't know if such a tool could be built. The team stumbled upon a video by Benjamin Peterson, aptly named Selective Testing plus Q&A from BasilCon 2019. In this video, Benjamin walked through a potential solution for target selection using Basil and cryptography. It was incredible to us that this was even possible. We quickly split up a prototype of the system and presented it to the team. This is exactly what we needed in the Tinder iOS main repository. From the start, our team wanted our target selection algorithm to be open source. We knew that other companies had implemented similar systems, but they're too tied to their internal code to be exposed publicly. We took great care to make sure this would not happen. Once we had finished our first release of BasilDiff, we began to run parallel builds using the legacy test workflow in BasilDiff. This allowed us to validate the tool in a real-world environment with real contributors. After about a month of parallel builds, we moved over to using BasilDiff for all builds in our tooling repository. The next logical step in our migration is building the Tinder application via Basil. Even before beginning the work on the Tinder target with Bazel, we knew that parallel builds were an absolute requirement. We had to prove that this new system was more stable, performant, and capable than the legacy build system. Knowing this, we realized that the configurations across the legacy build system and Bazel would need to be synchronized. This meant our migration pattern had to be fully automated, because we cannot require all developers to learn Bazel as part of the validation of the technology, the adoption of which was still far from certain. During the development of our Turtle toolchain, we discovered that we could consume human-readable YAML configurations to automate complex tasks for our users. This strategy of developing a domain-specific language and pairing it with code generation had already proven successful with several efforts prior to the Bazel effort. So it was a natural solution to our issue of automating the creation of build files. And here we can see an example of one of these YAMLs describing a module. So here's a flow diagram of one of our key tools internally called XCCLI. Developers run a command that code generates all configuration files in the repository. After XCCLI was deployed, we were able to run parallel CI jobs without interfering with the legacy workflows. After closing the remaining synchronization gaps between our legacy build system and Bazel, we were able to quickly validate the stability of our build and gather performance metrics. As expected, the Bazel build was highly performant and deterministic, and the caching layer was critical to this new performance frontier. We can see above that the statistics really speak for themselves. Despite still undergoing verification in our CI/CD pipelines, we had to turn our attention to the first App Store release of a Bazel-built IPA. Luckily, creating an IPA is very straightforward with Bazel, given that we've already paid the exhaustive cost of defining all required configuration as a prerequisite of building the application. Configuration that prior to Bazel was fragmented across tens of configuration files, build phases, Jenkins jobs, raw Xcode build commands, shell scripts, Ruby scripts, and Groovy scripts. Since the bulk of this work was already done, creating an IPA was as simple as invoking Bazel build. Our Bazel built IPA underwent a rigorous set of QA validations to ensure that nothing was missed in this build, and then ship it. We released the Bazel built Tinder application in October of 2021 without any issues. In our focused pursuit of solving the untenable growth in our build and test times in the Tinder code base, we neglected parts of the local development experience. In retrospect, we grossly underestimated the attachment of our greater engineering team to the legacy build system. Looking back, one regret of this phase of the project was simply not involving developers earlier. In the end, we spent a great deal more time working on developing buy-in on the Xcode project experience than any other phase of this project by far, assuaging developer fears and understanding the complexities of Xcode itself. Ending on a high note, here are some metrics from our migration to Bazel. Some of our CI metrics I had shared previously. Local build times were drastically reduced as well as part of this effort. Side wins came from static linking and discovering a number of unused or redundant assets. What's even more impressive is that these improvements were realized while the size of the code base grew by over 27%. Thank you so much for listening today. I hope you found this talk valuable. If you have any questions, feel free to reach out to me or with my contact information listed here. Enjoy the rest of BazelCon.